Hello, so this is my wrap up for week 4 of the course. So in week 4, we were looking at sorting and filtering our data, as well as analytics bias, okay? And so in a moment, I'm gonna go over to my keyboard, go over a few things in Jupyter Hub with Python. But before I get there, let me just talk a little bit about the discussion from last week where we talked about some biases. Again, great discussion. So if I summarize into some broad categories, I think a bunch of you talked about the issue of sampling and selection bias when data is being collected. So examples there, Uber. If we think about Uber, it's capturing a lot of rich data, but the rich data it's collecting are from people that are typically urban residents who are more technologically savvy. So it's not getting like a full picture of everyone that may, need transportation. Fitness trackers, I thought this was a great example. Fitness trackers are again capturing really rich data, but it's capturing rich data from people that can afford wearables, that can afford an Apple Watch or a Fitbit. So I think that's a really important thing to keep in mind. It's not a complete picture. So if you're like a health organization and you're thinking about using some data from wearables to track health outcomes, you're going to have to think about getting those wearables to people that might not have typically access to those wearables, right? Another theme that came up was over-reliance on technology, automation bias. So I think the example there, and this came up a previous week, Equifax's problems. So Equifax had some issues with inaccurate credit scores that were really due to an over-reliance on their automation. So not really using enough of kind of a human check on what the model was predicting or scoring. Another category that came up, misinterpretation of correlations, false causality. I talked a little bit about that last week, different examples. And so, if you think about Amazon or Netflix recommendations, those algorithms, we often want to attribute the idea that the recommendation algorithm is driving satisfaction with either Amazon or Netflix. But maybe it's not the algorithm. Maybe it's just that there are trends or the timing that has something to do with someone being more satisfied, right? So again, it's a little, even though there might be a correlation, that doesn't mean causality. We really have to be careful with that. And then the last little bucket had to do with contextual measurement, availability bias in decision making. So Starbucks app data, again, it skews more heavily towards people that are more tech savvy. Um, I thought this was a great example. So India, as well as the Chicago Public Schools Department, they rely much more on easily available data for metrics. So things like enrollment, rather than trying to track learning outcomes. Those are a little bit more difficult to get at. And often organizations will do that. They'll kind of look at performance based on stuff that's readily available when actually digging in and trying to get at performance metrics might be more difficult to get at, but actually might be richer data to look at. So really great examples, really great examples. Okay, let me switch over to my keyboard and walk through a couple things in Python. I'll see you on the other side. Okay, just a few things came up in Knowledge Check 4. First of all, I don't think I need to go over any of the questions from the Knowledge Check. In general, people did very well in the Knowledge Check. I think everyone got almost everything correct. But a couple of comments came up in the feedback, so I wanted to go over that. And one thing that came up is someone had mentioned that whenever they're trying to load in their data sets or read their data sets into their notebook files, they're getting error messages. My guess is that what's happening is that they've created a folder for like all of their knowledge checks, and the data sets are not in the same folder. So for instance, let's say I create a folder that I call knowledge checks, for all of my knowledge check work. Okay. And then I come into this folder and I open up a new notebook file and I'm trying to import pandas and then df equals pd. Oh, I'll say import pandas as pd. Let's use the alias pd.read csv. And I think the data set from last week was data UCI retail, online retail. .csv. And when you try to run this, you're going to get an error message because it's saying, hey, that file's not in here. Okay. So firstly, the reason I recommend that you have all of your data files in the same folder as your notebook files is that then you can just simply list the name of the file and it will automatically load. If you're going to do it this way, where you create another folder, you need a way to specify in the file name that it has to back up into the previous folder. The way that you would do this is you'd put 2 dots and then a slash. And notice that that worked. Basically, what this is saying is go back to the previous folder. Okay, so if you want to do it this way, that's perfectly fine, but you're going to have to, remember to add this in so that it goes back into the data folder. Okay, the key is if your data is not in the same folder as your notebook file, you have to somehow specify the path to that file. Okay, and unfortunately, it's not very user friendly. If you're ever kind of wondering like how to get to a file, you can always use Copilot or ChatGPT to look up that information, okay? Because sometimes that's not very easy to remember. Okay, so that's one thing that came up. Another thing that came up was, again, a little bit of confusion around the brackets versus the parentheses. And I know that I've kind of referenced this the last couple videos. I'll go through it one more time. Again, practice is going to help. But basically, the way to think about this is with brackets, there are 3 reasons, right? So let me actually change this into a markdown cell. Okay. So there are 3 reasons for brackets that we've talked about so far in this class. Okay. Reason 1 is I'm trying to access a column. For example, df bracket invoice number. Okay. And just to kind of show this to you, I'll do this here, df invoice number. That gives me that column, okay? So that's one reason that we use brackets, to access a column in our data set. A second reason is if we have a list of more than one column. And the example here, let's say I've got invoice number, and what's another column I could use? Description. Okay. So this is giving a list, and in Python, we use brackets for a list. Okay. If I come back up to this example, I have to add another set of brackets, description, and then another set of brackets at the end. And again, the inner brackets is saying here's a list of more than one column. The outer brackets are saying access those columns. And when I run that, I get those 2 columns, okay? So that's a second reason we're using brackets. A third reason we're using brackets that we learned last week is to use the loc command. And as I mentioned last week in the videos, this is really the only command that we use brackets for. So if it helps you, I kind of tried to explain why it makes sense, but if that doesn't make sense, then just try to memorize the loc command is always using brackets. Okay, so in this case, let me use a different example. Let me come down here, df.loc, okay, and let's say that we want, any row where the quantity, let's see, for quantity is greater than 100, okay? And let's see, df quantity, see, I'm missing brackets. I could pretend that I did that purposely. There we go, okay? And so, again, we're using 2 different brackets. These internal brackets are saying, give me this column, and in that column, I'm looking for any number greater than 100. And then these outer brackets are for the loc command. And the rationale that I gave for why it makes sense that the loc command uses brackets is because it's pulling out, it's accessing these rows from your data set. In the same way that this first reason accesses that data, right? That's accessing a column. Well, loc is accessing, in this case, a bunch of rows. Okay. So again, it's sort of locating data. This is locating data for just that column. This is locating data based on a logical condition. Okay. In pretty much most other situations, you'll be using parentheses. Okay. I'm hedging a little bit, and I'm sorry for this, but Python is what it is, right? I can't fix Python for us, but the exception is this week. This week I show you a command called rename, and in the rename function, to rename a column in a data set, there's an argument called columns equals, and then it actually uses these curly braces. That's something called a dictionary. And I think this is the only instance this semester where we have to use a dictionary. So I apologize for adding additional complexity. It is what it is. I didn't create Python. I'm just trying to help you get through it. But this is really an exception. And honestly, we very rarely use rename. So if this doesn't make sense to you, don't worry too much about that. It's the brackets versus the parentheses that come up much more. And so hopefully this makes a little bit more sense. Brackets are for these three purposes. Other than that, for the most part, except rename, we're going to be using parentheses. Okay. So there you go. Hopefully that helps explain a little bit more. I know that it's tricky. You just got to keep practicing it, and with time, it'll become a little bit more second nature. One last thing that came up. Well, two more things. One person had asked for more practice problems prior to the exam. I will post practice exam questions. The exam's not until the week after spring break, but I will obviously post some practice problems in the next week or two. Okay, so you'll have that in plenty of time to practice for the exam. Someone had also asked, why does it make sense to use Python versus using SQL or R? Okay, I think the person asked about Python versus SQL, but I'm adding on R as well. Honestly, SQL is used for something very different than Python. So you wouldn't be using Python to run SQL command. You can run SQL within Python. There are packages that allow you to run SQL within Python, but you're still running SQL. SQL is a query language that allows you to query a database, and you can't really. It's not really equivalent to Python, right? You would never run a SQL command to build a regression model. Next week we're going to look at regression models. You can't write that in SQL. So I guess the first point is SQL is very limited in its usage. SQL is specifically used when you're working with databases and you're querying the database. Okay. Python, on the other hand, is multi-purpose, right? We can read in our data, we can draw graphs, right? You can't use SQL to draw graphs. We can build models, okay? So I don't think the comparison between Python and SQL makes sense because SQL really is doing something different. I do think the better comparison is Python versus R, because much of what we can do in Python, we can also do in R. And so why might you use Python versus R or vice versa? It's really a matter of taste. So in the MBA program, we're presenting you with both because we want you to feel comfortable working with both. If you're on the job market and you try to get a job, you may not know, are they using R or are they using Python? They're probably using one or the other. And so by having some exposure to both, it makes you more portable as an employee, right? It makes you more flexible, that you can kind of work with both. And the point is, in DA1, you're not becoming an R expert. In DA3, you're not becoming a Python expert. But you're getting enough of a background in these that, let's say you start working at a job that now uses Python, you've seen it before, right? So it's not like completely new. And that really does give you a huge leg up over someone that's never ever done anything in Python. Okay. So honestly, some places use R, some places use Python. I will say that Python is used more for more applications. Like you would never write a program for like a computer game in R. R is very specifically about data analysis, whereas Python, computer games are written with Python. So obviously that's way far afield of what we're doing in this class, but I guess maybe that would be the preference for Python, is that it's used in more applications, and there are probably more places these days that use Python. But R is very powerful when it comes to data analytics. So I don't want to say that doesn't have its use, and there are places that are still using R. So anyway, hopefully that's helpful. One last thing before I leave my keyboard, I just want to point out it's due this upcoming Monday, but in case you didn't see it, so there's this. Well, there are two things due this Monday. There's the coding project profiling assignment. This is you using the data set that you're using for your coding project. And basically, you're going through the same types of profiling steps with your own data set that I had you do in that first assignment, as well as in class. Okay, so that's one thing that's due this upcoming Monday. The other thing is this connections exercise. And the point of, there are going to be two connections exercises in this semester. This first one is all about evaluating code that AI generates. And the point that I'm making with this exercise is that when you use like Copilot or ChatGPT to generate code for you, sometimes it overly complicates things. It overly complicates the code, which presents problems in terms of, first of all, you may not be aware of what it's actually doing because the code is so complex. Or secondly, the more complex the code, the more likely there is for there to be a mistake. So in general, the simpler the code, the better. Okay. And so I've given you a block of code using the Strike Reports partial data set, which, by the way, we've worked with to profile. So you should be able to refer back to some of that code from that week. This is code that Copilot provided for me to profile this data set. And what I'm asking you to do is, first of all, identify at least 5 ways that this could be modified and simplified based on the code that we covered during the week of profiling. And then I've given you the code, and I want you to actually simplify this code. So basically, at the end of you simplifying this code, it should look very much like something that we would have done 2 weeks ago when we were profiling data. Okay? So that's your task, is to try to edit this code, make it simpler, make it more in line with the type of code that we covered in class. Okay? And then finally, I'm just asking you to write a few sentences to reflect on a potential risk of using generative AI tools for coding without critical review. Okay? So that's another assignment that's due this upcoming Monday. Okay? Hopefully that's helpful. Okay, hopefully you found that helpful. So just reminders for this week. This week we're looking at feature engineering. It's a heavily technical topic. There's really no managerial topic this week. And because of that, there's no discussion board. So what's due next Monday? There's a knowledge check 5, but there is no discussion post. So in place of the discussion post, I'm asking you to complete an assignment I call the connections exercise, which is really around how to work with an AI tool when you're coding. This first connections, well, actually, on the video I just, when I was on my keyboard, I went through that exercise. So I'm not going to repeat myself here, but that's due Monday. And that's in place of the discussion post. And then additionally, the first step in your coding project is due Monday, the profiling step. Okay, so knowledge check 5, connections number 1, and coding project profiling. Those are all due Monday. Okay. I'm currently grading your first assignment on profiling, so I'll try to get those grades back by early next week and give you feedback on that. Other than that, have a great week, and I'll see you next week. Bye-bye.